Question 31, a tough question here. When you get any kind of amine, this is a tertiary amine, but when you get any kind of amine with an N in it, either a primary, secondary or a tertiary amine, then it will react with halogenoalkanes. So haloalkanes like CH3Cl, something like that, and the lone pair of electrons attacks the C of the polar C to Cl bond, and the bond breaks between the C and the Cl. Electrons move on to the Cl and form Cl minus, and this joins on with a plus charge. So it's a nucleophilic substitution with a haloalkane, where the N, the lone pair of electrons on the N, attacks the C, the polar bond, the delta plus on the C, and the Cl minus is released. So this replaces the Cl using its lone pairs of electrons. This is a nucleophile, a lone pair donor, attacks the C, the delta plus on the C, and the lone pair of electrons, the pair of electrons in the bond move on to the Cl to make a Cl minus with a pair of electrons with nucleophilic substitution. So your answer is D. It's part of the process when you react any amine with a haloalkane, and it keeps replacing it in a series of steps until you end up with a quaternary ammonium salt used for cationic surfactants or detergents. Which polymer is least likely to be biodegraded after several years in a landfill site? Well, you need to know about amide or peptide links and ester links as well. So Kevlar and nylon have got amide links, a C double bond O NH link, sometimes called a peptide or an amide link. So they're polyamides. Terylene is a polyester, got a carbon to oxygen double bond O link. And all of those are formed when you react something like, so for Kevlar, maybe you've got COCl and acyl chloride with an NH2 and amine, and they react together to form a peptide link, and the same for nylon, where you've got an NH2 and a COCl, and they make HCl in a condensation reaction and an amide link. Or maybe terylene, you've got something like a carboxylic acid and an alcohol group forming a C double bond O ester link in there and making water in a condensation reaction. Or maybe again with a COO, a carboxylic acid group, with an acyl chloride group, a COCl, and making HCl. But in any case, these have got either amide links, NHCO, or ester links, COO, in there, A, B and D, and you can reintroduce water. So when you make them, you make water, but you can reintroduce water, a process called hydrolysis, breaking bonds using water, and maybe you've got a little bit of acid in there to catalyze it. But polythene is an addition polymer. So what's happened is the double bonds between the carbons have broken and made single bonds and a long chain of carbons. And those carbon bonds are very, very strong. So that backbone of carbon to carbon single bonds formed when an ethene forms, reacts together in addition polymerization reaction to form double bonds, forming single bonds. Those single bonds are very strong and they won't be hydrolyzed by water, they don't react.